Hello dear friends, we are still on with the episodes of acid-base theories, and in this episode we are going to talk about the Lewis acid-base theory. This is the last theory of the concepts of acid and bases, starting with Robert Boyle, followed by Arrhenius, again followed by Laurie Bronsted, and now Lewis acid-base theory. In just the previous episode, we did talk about the Laurie Bronsted limitation with respect to a compound BF3. So I'll write once again the same compound BF3 so that we can easily understand the Lewis acid-base theory. First, if I talk the principle of Lewis acid-base theory, it was an interesting principle given by G.N. Lewis. He just ignored all the concepts of Arrhenius with respect to proton and hydroxide. If you consider Laurie Bronsted, it was with respect to the proton exchange. G.N. Lewis just determined the theory with respect to electron. That means his theory was based on electronic structure. And so till date, till date, there has been no limitation for Lewis theory. So this is the theory which is superior to all the acid-base theories, and that is Lewis theory. According to Lewis acid-base theory, a compound, if accepts an electron, or you can say electron pair, then it is an acid. And a compound, if loses an electron or electron pair, then it is a base. So he simplified the theory with respect to the electron gain and electron loss. So there was no limitation left behind. It was because it was based on electronic structure. So that is why I said that it is the superior theory in all the acid-base theory concepts. Now, I talked for the limitation of Laurie Bronsted, and there I had considered BF3 in the previous episode. We'll just proceed with the same thing. I am taking over here BF3 and I am reacting it with, let us say, NH3, that is ammonia. Fine. Now you can see this ammonia is rich with electron. Ammonia is having nitrogen, and that nitrogen is rich with electron. Why? Because nitrogen has got atomic number 7. That means it has got 5 valence electrons. Out of 5, 3 have been shared with hydrogen atoms, and so 2 are left in the form of lone pair. So what can happen over here? This nitrogen has already completed its octet. You can see nitrogen has completed its octet. Whereas on the other hand, BF3, in that boron has got only 3 valence electrons, all 3 bonded with fluorine. Fluorine completes the octet, but boron has not yet completed its octet. It is left with only 6 electrons after sharing 3 electrons. So what happens? This nitrogen provides a lone pair to boron. Why? Because boron is in need of electron to complete its octet. Of course, nitrogen is not losing electron to boron forever. Otherwise, it will be unstable with only 6 electrons. So what forms is a coordinate covalent bond between nitrogen and boron. And as coordinate covalent bond is formed, both nitrogen as well as boron are completing their respective octets with respect to those or that lone pair. So here boron gets the electron pair. Now it is well satisfied with 8 electrons. Nitrogen was already having 8 electrons, and that is how the overall stability scenario has come to an end. Now the concept of acid, that is this Lewis acid-base theory. What it states that a compound, if accepts an electron or electron pair, then it's an acid. So here boron accepts an electron or electron pair. So it is an acid. So here I can say that BF3 is acid. And on the other hand, he said that a compound if loses an electron or electron pair, then it's a base. So I can now say easily that ammonia is a base. So you can recognize a compound, any damn compound you come across. Suppose I take one more example between water and ammonia. I'll definitely perform a comparative study. Okay. Water and ammonia, out of these two, which will act as an acid and which will remain as a base, obviously. Water has H2O. Okay. According to the concept of electron gain and electron loss, the nitrogen has got a lone pair. Fine. So what happens? This water, first of all, you know, water is basically amphoteric. It is neither an acid nor a base. But we want to compare it with respect to ammonia. So what I am doing, I am ionizing water into H plus and OH minus. Okay. So what happens? This lone pair on nitrogen will invite this proton H plus towards it. Fine. So obviously, other way around, what we can say, that it is losing its lone pair. The lone pair remains no more on nitrogen. So what happens? It is losing its lone pair. On the other hand, I can say that OH minus is gaining a lone pair because it is having a minus charge now. So what happens over here? This water is accepting the lone pair from nitrogen. If it accepts a lone pair, it is an acid. This is losing a lone pair, so it's a base. As it accepts a lone pair, what happens? What finally I can say that this proton gets attracted towards NH3. So this NH3 converts into NH4 plus with no electron left on nitrogen. And as H gets away to the lone pair, OH minus is left alone with minus charge rich with electron. And so I can say that water is acid with respect to ammonia, which is a base. So this is a comparative study just to make the things simple, that you take water with respect to any compound, you can justify it with respect to Lewis whether it's an acid or a base. Again, it differentiates. If you consider HCl and if you consider water, then this time this water having oxygen which is having the lone pair will attract the proton from HCl. So this time the proton of HCl gets attracted towards water. On the other hand, what you can say? The electron is lost by water. One which loses electron or electron pair is a base. One which gains, because Cl will be formed with a minus sign. So it's an acid because it is gaining electron or electron pair. So accepts electron is acid, loses electron or electron pair is a base. So you can understand in the simplified version over here, according to Lewis acid-base theory, that any compound, any damn compound you come across can easily be recognized as an acid or a base. Comparative study, acid or a base with respect to Lewis theory because it is based on electronic structure. Now in the next episode, I'll talk regarding the superiority, or I'll compare Lewis theory with respect to Laurie-Bronsted theory, so you'll still realize that how it is most superior. Till then, prepare all the episodes with respect to acid-base theories. Robert Boyle episode, Arrhenius episode, Laurie-Bronsted 3 episodes, and Lewis acid-base theory episode as well. Prepare well, come prepared for the next episode where we can prove that Lewis will be much superior than Laurie-Bronsted. Till then, goodbye and do take care of yourself.